The overall goal of this procedure is to synthetically increase the lens aperture of a scanning imaging platform. This is accomplished by first capturing 3 low-resolution, differently defocused images of a target while moving along the optical axis of the system. The second step is to shift the entire imaging system perpendicularly, and then take 3 defocused images of the target. Next, shift the imaging system to the other side of the optical axis and capture 3 more defocused images of the target. The final step is to numerically retrieve the optical phases in order to determine the optical fields, and then properly combine them to achieve a super-resolved image. Ultimately, a synthetically increased lens aperture is generated along the direction of movement, yielding higher imaging resolution.
The main advantage of the proposed technique over other time multiplexing super-resolving approaches is that our technique is passive and therefore it does not require projection of encoding patterns that are later on used to obtain the super-resolved image.
This experiment is normally performed in relative darkness. However, some of the video is filmed with the light on in order to better visualize the protocol. Begin setup with the rough alignment of the laser, beam expander, lens, and camera on the same optical axis. Mount both the lens and camera on a translation stage to allow for subtle movements perpendicular to the optical axis. Additionally, mount the camera on a translation stage for small motion parallel to the optical axis.